So we've kind of established now that your world is built from this model. Your world is this model built from information, and that sensory information, the role of sensory information, is essentially to guide the updating of the model from moment to moment. I've said that so many times, moment to moment. Now, the way that we kind of thought about this was kind of like, so sensory information selects certain states. So there are certain possible kind of next states of the cortex. The cortex, the set of cortical columns that makes up your world, is in a particular state at any point in time. And the next state, kind of the update, if you like, of your world, is kind of selected by sensory information. And I also told you that this was kind of an old way of looking at things, kind of a classical way of imagining the way perception works. The idea that sensory information is somehow kind of driving the construction of your world model. However, I also told you that we kind of understand perception a little bit differently now. We really think things work actually kind of in the opposite direction, in that rather than allowing sensory information to kind of drive the construction of your model, instead your brain is attempting to use its model. It has this model constructed by your brain from information, and of course that model evolved as a way of making sense of the environment, to learn about the structure of the environment, and so what your brain can do with that model is essentially to predict the kind of sensory information that it expects based upon what it's learned about the structure of the environment, and thus the structure of sensory information that it normally receives. So it's a bit confusing, but what I want to do in this video is really make that clear, exactly what I mean by that. What do I mean by predicting sensory information? And we'll look at this from a kind of from our usual diagrammatic perspective, where we use our kind of diagrams to represent the cortex and understand it like that, as well as actually a couple of real-world examples. So hopefully by the end of this video, you'll have a much clearer understanding of what I mean by the brain predicting sensory information, and why that's a much more efficient way of working than simply allowing the sensory information to kind of drive the construction of the model. Okay, anyway, I'll stop talking. Well, I won't stop talking, but I will. Let's go to the board and actually let me kind of show you how this works. Okay. So this is kind of the way that we've been thinking about sensory processing so far. The idea that sensory information enters the cortex, through the primary visual cortex, for example, and is processed through this hierarchy of sensory processing. So the lower order end, the first level of the hierarchy, where kind of lines, their orientations, edges, textures, basic features are picked up, and then this information is then passed through this increasingly complex levels of the hierarchy until finally we reach the highest end, where things like faces and animals and subway trains are picked out. So let's look at this now in terms of the actual cortex structure. So this is of course the model, should be very familiar to you now, this model of the cortex and the cortical columns, and you will notice that I've separated them out in that to kind of emphasize the hierarchical nature of this model. So we have this kind of, I guess this is kind of low order, and this is high order. So when we initially discussed the role of sensory information, we had this idea that the sensory information here kind of selects a particular state. So this state, for example, is selected by the sensory information by stimulating a particular set of cortical columns, and this is what's sometimes referred to as sensory matching. The idea that sensory information is matched to particular states of the cortex or particular patterns of activity of the cortex. So let's look at this same idea, but from a hierarchical perspective. So first of all, I've kind of blacked out two of the levels of the hierarchy, first of all. The reason for that is I want to kind of emphasize how this process works, or at least the kind of classical idea of how perception works. So what you're seeing here is actually, there's no different to what you are seeing here. It's just this was a much more simplified way of looking at it. But the reason we've made this whole thing larger and more complicated now is so that we can include this idea of the hierarchy. So there's no new idea here really, simply that we can now include the hierarchical nature of the cortex in our explanation. So again, nothing unusual here. We have sensory information that enters the lower order visual cortices and picks out things like lines and orientation. So that's what's happening in this lower order level here. So this is low order. And you can see that a particular state has been selected here by the sensory information, illustrated by the activation of this particular set of cortical columns. So then what happens is that particular pattern of activation of this lower order part of the visual cortex then triggers or selects a particular state in the medium order cortex. So here we can see another state. So this is medium order, I guess you could call it. And here we can see another particular pattern of activation that has been essentially selected by the lower order. And then finally, this medium order pattern of activation then selects a state in the higher order. So overall, we have this pattern of activation which represents your entire world at this point. It was constructed in a hierarchical fashion from sensory information through to the selection of a lower order state, which selected a medium order state, which then selected a higher order state, and this generates overall an overall state of cortical column activation, which is your world model. So this is this simple representation at the bottom here. What is meant by that is this. Now, this is often referred to, this way of looking at things, as bottom-up information flow, because the information goes from sensory information, which is kind of, I guess you could imagine that being right at the bottom of the hierarchy, up through the lower order visual cortices to the higher order. So the information is flowing from low to high or bottom up. So this is a classical way of thinking about perception as bottom-up information flow through the hierarchy of the visual cortices. Okay, so that's the classical way of thinking about perception. Sensory information flows upwards through these increasingly complex levels of this cortical column hierarchy, visual processing hierarchy. However, it's not the way we now think that it's not the way now we think. It's not how we now. I can't even pass a sentence. Okay. However, we now think of, here we go, this is it, this is the one. we now think that cortical sensory processing actually kind of works in the opposite direction, in that rather than sensory information driving the update of your cortical model, which would be implied, right, by this bottom-up information flow. Sensory information, it's coming from sensory information. Sensory information comes in at the lower end of the hierarchy and then is passed up. So it all seems to be kind of driven by sensory information. But actually, that's not a particularly efficient way to work. Why? Well, let me give you an example from kind of the real world, well, from a cartoon. So this is a still from a very popular cartoon at the moment, which is why I chose it, called Midnight Gospel on Netflix. You can watch that. It's very, very cool and kind of psychedelic, so I thought it was very appropriate here. Now let's think about how this how this would be animated. Now, of course, in animation, you've got each frame is a still image, and then a series of these still images are put together to generate the animation. Obviously, everyone's aware of, basically that's how an animation works, right? But of course, when you're constructing the animation, what you don't do normally is to kind of redraw the entire scene, the entire image, the entire frame with each frame update. That doesn't make any sense. What you would normally do is have is the kind of the background material, so the background image, anything that's not going to change, basically, you would keep that constant, and then you would only update the things that are moving. So in this image, you can see this guy, I forget his name, but he's clearly moving around within this animation, whereas the background is probably static. And so you keep the background the same. You don't change it. You only change the moving image. And of course, everyone's aware that that's basically how animation works. Now, it's also kind of how the brain works. This kind of bottom-up information flow way of thinking about sensory processing is kind of like redrawing the entire frame with each frame of the animation, because with every passing moment, your brain is updating its model based upon sensory information. All of this sensory information is coming in, and your brain is kind of reconstructing the model from scratch with every moment. And that's obviously not a very efficient way to work, because, for example, right, I live luckily quite near the beach, and if I walk down to the beach and kind of stare at the ocean, my brain is constructing a model, and that model is experienced as this beautiful scene of this turquoise ocean and blue sky, etc., etc. Now, does it make sense, considering that this model is going to be fairly static and relatively unchanging every moment, does it make sense for my brain to kind of reconstruct the entire model from moment to moment? No, it doesn't. However, if I was stood watching the ocean and suddenly a dolphin, let's say, leapt out of the water and then was eaten by a great white shark, came and it ate the dolphin, and there's blood in the water, and a grisly scene, absolutely grisly scene, just the terror and violence of nature. That's never happened, but I've sat there watching sometimes for hours. I'm not even sure they have great whites in Okinawa. I don't think they do. They have dolphins. I've seen dolphins, but not great white sharks. I don't know whether it's a good thing or a bad thing. Anyway, I digress a little bit. So when you're looking at the water, the scene is pretty much remaining constant. Your world model doesn't need to be changed. However, when the dolphin leaps out, then obviously the model needs to be updated because there's something new there. And that's kind of the way the brain works. The brain has this model, and if it thinks its model is correct, then it will kind of predict the information that it's likely to receive next. So when I'm looking out at the ocean, things are staying pretty the same. The brain pretty much knows what the next pattern of sensory information is going to receive, and it's going to be very, very similar to the pattern of information that it received the moment before, right? Because it's a pretty unchanging image. It's only when the dolphin leaps out that the brain catches on to that information, something that didn't predict, and actually will process that information. So the brain it's a predicting machine. It takes its current model and it says, okay, if this model is correct, this is what I should expect to receive. This is the kind of sensory information that I could expect to receive in the next moment, slightly in the future. If I'm correct, I don't need to know about it. I don't need to know about that sensory information. But if I'm wrong, and some sensory information enters the brain that I didn't predict, the dolphin leaping out of the water, then I need to process that information because I need to update my model because something new and surprising and something I didn't predict happened. And that is how your brain actually updates its model. That is perhaps not 100% clear. Don't worry. Maybe it's because I'm not explaining it very well, but it's actually a little bit, it's not that intuitive, I don't think. And it is kind of slightly backwards. It's the opposite way that most people think about sensory information. So, okay. So let me just give you an example of the way this works. So here you can see a blue line, and the blue line is going to rotate. Now what you'll notice is that the steadily moving blue line is accompanied by a flashing blue line. Now if you look at it, you should see that the flashing line actually lags behind. So this is called the flash lag effect because, well, the flashing blue line lags behind the steadily moving blue line. However, in reality, these two lines are always perfectly lined up. So what's going on here? Well, this is perhaps kind of debated a little bit by neuroscientists, but it serves as an example of this kind of prediction process. It's actually called predictive processing. This kind of predictive process in action. So this steadily moving blue line, the brain knows exactly what's going on. Your brain is able to predict exactly what this line is doing. It knows exactly where this line is going to be in the next moment, always. And so basically your brain isn't really processing that sensory information at all. There's no need for it to. The model that it has of this blue line moving, which is obviously what you experience, is working. It's perfect. So it doesn't need to process that information. However, the flashing line is surprising to the brain. It doesn't predict it because it's kind of this irregular flashing blue line. And so that information, that sensory information, is processed. And because it's processed, when I say processed, it actually passes through these hierarchical levels of the visual cortex that we discussed. That takes time. And it's thought that that's one of the reasons why this blue line tends to lag, is because essentially the brain effectively has kind of like two models. The continuously moving blue line model, which is easy to predict, and your brain doesn't need to process, and then the flashing, and that's the kind of new information, surprising information your brain fails to predict, and the time, because of the time it takes for your brain to process that information, the surprising information, the unpredicted information, this causes this slight lagging effect. Okay, so in the next video we'll have a look at this predictive processing in a little bit more detail and actually apply it a little bit more closely to the brain. I'm kidding. However, if you do want to support the production of future courses, or you just want to leave a tip, then there are virtual tip boxes below. There's PayPal, Ko-fi, or Ko-fi, whatever it is, even a Bitcoin address if that is your thing. Minimally, please like and subscribe. It really helps me. And please follow me on Twitter and Instagram if you use them, Alien Insect. And I think that's about it. I hope you're enjoying the course. Thank you.